Hello everyone, my name is Miguel de Guzman. Welcome to my video, and today we will be talking about center of mass. What is center of mass, you may ask? Center of mass is a position defined relative to an object or system of objects. It is the average position of all the parts of the system, weighted according to their masses. What it meant was any object it may be living or not, has a center of mass, meaning I have a center of mass, you have a center of mass, and this unsolved Rubik's Revenge has a center of mass. Now, since this Rubik's Revenge is a uniform density, its center of mass is at its centroid, as well as to all the objects with uniform density. On how force is affecting the center of mass, I will show you. As I push the Rubik's Revenge in its center of mass, the whole cube started to move. However, if I only push, for example, its side, it will only turn around the center of mass. Here are examples of geometric shapes with a center of mass. As you may have seen, the center of mass of a uniform disc shape would be at its center. Therefore, sometimes the center of mass doesn't fall anywhere on the object. The center of mass of a ring, for example, is located at its center where there isn't any material. So how can we find the center of mass on any object or system? How to solve for it when you see it in a problem equation? Simple formulas used to find the center of mass depends on the object's position, whether it is placed along the x-axis or it is placed along the y-axis. It is as it shows. Center of mass in the x-axis is equals to m sub 1, which is the first given object, times x sub 1 being the distance away in the x from the given object, plus m sub 2, which is the second given object, times x sub 2 again being the distance away in the x from the given object, then all of them divided by the sum of all masses. Let's have a quick sample problem. Here at the screen shows the given in the formula. Now what would you do is x cm, or distance of x to the center of mass, is multiply mass 1, which is 2 kilograms, times the distance, which is 4 meters, plus mass 2, which is 4 kilograms, times the distance of 10 meters, then divided by 2 plus 4, or 6 kilograms. Then after computing, the center of mass should be 8. Therefore, the distance of x to the center of mass is 8 meters. You could add another mass. It would just be adding m sub 3's in the formula. For example, if the problem given has 7 objects in there, then you could go on m sub 1 up till m sub 7 divided by the sum of all masses. This all applies as well in the y-axis. If the problem given has a mass in the y-axis, to solve it, you would need to solve for the x-coordinate as well, as choose the distance in the y-axis, and then you are going to use the same formula only with y sub 1, y sub 2, and so on and so forth. I thank you for listening to this brief explanation of center of mass. I wish you understood even just a little info about what I've just said, and I bid you goodbye.